All right, well, let's talk about malware. What does it stand for? Malware stands for malicious something. Malicious software. Malware is malicious software. Who creates malware?
Malicious people. Malicious software developers.
Malicious software developers that are hard at work in dark rooms. Now, you want to know what's really scary? The malicious hacker could be in elementary school, because these kids are smarter than a lot of us nowadays when it comes to developing this kind of stuff. So they're developing the malware. That's the first step. They're developing the malware. What can malware do? Malware can do a variety of things. Malware can cause your device to slow down or actually become completely unresponsive. You've probably heard of this or seen this before. Or even, I guess even scarier, is it can steal our data. It can steal our credentials, our username and password. It can steal our credit card information, our social security information. In fact, what can it steal? It can steal anything that we supply over the internet in a web form. We don't really think about this when I'm going to go make an order with the Office Depot. I give all my information, my name, my address, my email address, my phone number, and even worse, my credit card information. I'm just supplying all this. Why? Well, because it's using SSL. It's using HTTPS, so I feel very, very safe. Problem is, malware is happening, and well, I'm jumping ahead, so I'm not going to jump ahead yet. But anything users put into a web form can be stolen by malware. So how does it get on our computer? So first, it's important to remember, malware is malicious software. What does that mean? Software. What is software? Software is like Microsoft Word. And Microsoft Word cannot just magically appear on my computer. How do I get Microsoft Word onto my computer?
Only have a lot of money, then do an install.
We have to do an install. We have to install it. And malware is the same way. So why would people install malicious software on their computer?
They wouldn't knowingly.
They wouldn't do it knowingly. Let's look at an example here. We got Grandma, right? And she's happy because she's buying some gifts for all the grandkids. And then all of a sudden she gets a little pop-up, something that looks, oh, okay, this looks concerning. I better click on OK and start the repair process. But you know what happened when she clicked on OK is she didn't start a repair process. She installed malware. So that is a very common way that malware gets installed. And now she's confused as to what's going on. We've got to go help our grandma. She got malware. Another very increasing trend in malware is called attachment-based malware, where we get emails. They look kind of like phishing emails, but they're not. They include attachments that look like PDF files or HTML files. This is actually a real email that one of my coworkers got a year or so ago. And we took a screenshot of it. And as soon as we select to download that attachment, we're installing malware. So unfortunately, it's very easy to get tricked into installing malware. So now we know who creates it. Now we know what it can do. Now we know how it can get on our computer. The next thing we're going to talk about is what triggers malware. Once it's on my computer, what triggers it to do something? So we're going to assume malware is already on this computer. Malware is designed, most malware programs are designed to listen for when users access financial web applications like wellsfargo.com or the Royal Bank of Scotland, or they're managing their stock With E-Trade, that's how we can do our employee stock, if you have that available to you. In the US, we also have our 401k retirement plan, which we manage using Fidelity. These are all financially based websites, web applications, and these are all typical targets for malware programs, those guys who are writing them. So what happens is the malware is just sitting on the computer and it's basically listening for what I'm doing and where I'm going. And so as soon as I go to a site like wellsfargo.com, that activates the malware. That triggers the malware. It makes it jump up and say, oops, something's happening. I can do something now. And here's an example of something it might do. So when I went to my Wells Fargo website yesterday, this was the login page. Username, password. When I go there today, now I'm seeing a little bit of information here. Due to some security concerns, they're now also asking for my personal identification number as well. Maybe even more so, maybe even more. Maybe they're also asking for my account number and my PIN. Now, a savvy user might look at that and say, that seems suspicious. Maybe this is a phishing website. I was taught to look at the URL and see what that looks like, but it looks valid, wellsfargo.com. So clearly they've had some security issues at wellsfargo.com, so I'm going to go ahead and put in my account number, my PIN, my username, and my password and submit that, and now malware has succeeded. By the way, the user might do anything. They might look at the security certificate and say, is this, yeah, that's the correct, okay, so this is not a phishing website. So it can be very hard to not get tricked. And what's terrifying is when the hacker gets their malware created and it's listening for all these sites, they can get it on all these devices all around the world. And the malware on all these devices is listening for just any different kind of financial based website. And it doesn't even have to be financial based. It could be anything. And it's just waiting for these users to go to these sites and do something. So how does it get on those devices? How does the hacker, how do they do what they do? They're very clever. They start off by developing the malware, whatever it's going to do. In fact, here's an example. This is just a very simple, common look at what malware does. So you'll see here, it says anything that matches the host name star Wells Fargo star. What I want you to do is I'm going to put in some JavaScript code to insert a field into the document object model. And all they have to know is what our web page looks like at Wells Fargo. And that's easy to find out. They just go to wellsfargo.com, look at our login page, and they can look at the document object model like you guys just did, and they can easily see how and where they would insert a field onto that page, very easily. But anything that has to do with bankofamerica.com, they're going to add a button and replace some text, and so on. So this could be just an extremely long file of all of these host names, and each one can do a custom insertion, JavaScript insertion, to do whatever the hacker writes it to do. So they've written their JavaScript now. They've written their malware. They now are going to send using multiple methods. They can send out mass emails with attachment-based. Most of them do things like social media. Put a Twitter, hey, this is really cool, check this out. Click on this link. They click on the link. Do whatever method they can. They have all these methods. And as long as they get users that click on that link or click on that attachment or do whatever, and they've now got the malware installed, now this guy's a success. He's done the hard work. And so now what happens, this is a little bit more of a drawn out picture of what that malware does. So the first thing is most hackers use what is called a drop zone. And a drop zone is typically just some sort of a web server sitting out there on the world. More often than not, it's actually a legitimate web server that's been hijacked by the hacker, which can make it even more challenging for us trying to stop it. So now the drop zone's just sitting there. Then the user, they're going to go to their banking site, wellsfargo.com. They get their login page. But as soon as they went there, that triggered the malware. And then the malware did what it was told to do, which was insert a new field. So that's what the user sees. So the user is now going to go ahead and fill in their username, their password, and their PIN, and they're going to click on Go. The web page is still going to send that request to the web server like it normally would. The web server, the request to web server would look no different. To the user, their response would look no different. They'd still get their next page. Nothing would change for the user. But unbeknownst to the user, the malware has captured all of that information in clear text, no less, and is now sending it to the drop zone. So we can now see the hacker now has access to the website I went to and my username and password, and because he asked for it, my PIN. And he can do that for all those users that got malware on their computer for Bank of America and Wells Fargo and Bank of Scotland and Bank of UK and Bank of Japan or wherever. Now that's scary, isn't it? Is it a little scary? This is real stuff. You might have malware on your home computers right now. While you're here, your kids are on your computer sending off all their credentials to all the drop zones out there. Should be scared. And here's another way that hackers do this, because think about, there's one drawback to successfully creating malware. So I've written up a malware, I packaged it, sent out all my emails, and I got the malware on Richard's computer, so that's great. But a couple days later, I'm like, I've got a new website that I really want to add to my malware program. So I'm going to add that website, but unfortunately, people that already have it on their computers, it's not going to affect them unless I can get an updated version on their computer. Maybe that's possible. Instead, they could use external URL injection. So the malware, instead of the malware specifically saying, here's what I want you to do, all the malware does is call an external JavaScript. We already talked about that earlier today. A lot of sites reference external JavaScript. So now, my computer is going to, and again, these scripts can either be on a hacker's personal website or a hijacked server. They're very cunning in how they do this. So now, as soon as my malware runs, it's actually going to go and get the most current version of that malware JavaScript code, and that'll affect my browser session. That's another risky one.
I've seen them send instructions over public Twitter accounts that were created by bots. So these, instead of going to a known black site or something bigger, the malware will reach out just to the Twitter account to receive instructions and then reprogram itself and then execute.
And well, you know, on top of what you just said there, I heard something recently, and these guys are getting smarter and smarter and smarter every month. And so that's why we have to have our products get smarter and smarter and smarter as they do, staying on top of them. It's really hard. But thankfully we have WebSafe. It has a lot of features specific to malware detection. It can detect when that malware is on the user's computer. It can check for the external URL injection we just talked about a second ago. It can look to see if something's manipulated on the page, if a new field is added, or a new form is added, or if something, or if known JavaScript signatures are present. malware JavaScript signatures. And then it also can make sure that text hasn't been added or removed from the page. Anything that it does find, that's what triggers the alert with specific information. Now, there's another big difference between WebSafe and ASM. Huge difference. With ASM, as you saw, it's a very powerful product. It really is a very powerful product. But there's a lot of configuration. I'm not going to lie. There's a lot of configuration and a lot of learning curve really to learn the product well. WebSafe, not so much. I don't think WebSafe could be any easier to use. I really mean that. So here's how we're going to set this up. We're going to first create what's called an anti-fraud profile. And by the way, once I create an anti-fraud profile, what do you suppose I attach that profile to? Is it becoming redundant? The virtual server? So I'm going to go here to my anti-fraud profile page and click on Create. You'll see that all the options we talked about are available, so I can create a profile that includes malware detection and phishing detection, application layer encryption, and so forth. I can always add later if I don't select them all from the get-go. Then I give it a name, very simple. This alert identifier, this is what creates a connection to the Security Operations Center. So when alerts are sent from this profile to our Security Operations Center in Warsaw, this tells them what customer this is referring to. And then we have logging. This is where the alerts go. That's in summary, that's all I'm going to say. It's not, don't get bogged down by it. In this pool is the information about the SOC. So this is where WebSafe sends the alerts. And this is all you need to set up the profile. That information, that's it. But now, I want to start doing some stuff with the profile. I want to use it for malware detection. So over on the left, you'll see URL list. And we're going to click on Add. It's really important to understand and to explain that everything in WebSafe is at the URL level. We create detection and so forth at the URL level. And that's fine because most applications like Wells Fargo, the first page everybody gets to is the logon page. Nobody can bypass the logon page. So if I got malware on my computer, we're going to find out on the logon page. So there's really no need for me to go add protection for every other single page on my Wells Fargo banking site. So I'm going to add this for my logon page. Click on that little icon on the left because what I want to do now is see my left menu. And this is where you can see all of our options for malware detection and phishing detection and so on. But I'll start with my malware detection. Everything inside of WebSafe is basically checkbox options. Unlike, again, ASM, where we've got all these components of URLs and parameters and file types and staging and so much. It's a powerful product, don't get me wrong, I love it, but this couldn't be easier. It's simple checkbox options. In fact, you'll notice that by default, most of these options are already enabled. There's some more options down at the bottom, such as the malware, JavaScript signatures, and so forth. So now I've got my profile for the login.php page. It's got malware detection. Now I just simply need to come to my virtual server, my security policies page, and a little bit down here at the bottom, this is where we have our anti-fraud profile. We will enable that and select the correct profile. So again, think about what this page is so cool, this page here. On this one page, we can enable ASM stuff. We can enable our ASM. We can enable WebSafe. You would also can do a DOS profile here, our logging, all done here on this one page. So now let's take a look at how this works once I have it enabled, once I have this profile in place. And I have an animation on here I spent quite a bit of time on. So if I don't get a reaction, then I'm going to just leave. It should be obvious when the time comes. So now the user's infected. We've got the drop zone. Everything's in place. Now the only difference is the application the user is accessing is behind BIG-IP using WebSafe. It's got a virtual server for the banking website that has an anti-fraud profile attached. So the user, oh, and by the way, I've got two differentiators, and this is big for you guys in sales. These are actually really big differentiators. The first differentiator between us and our competitors solutions don't have a BIG-IP. So our competitors' solutions, let's say we've got 10 web applications across 15 web servers, or 50, excuse me, web servers we want to add fraud detection for. For our competitors, like Trusteer, they have to go and write in code. They have to write in code into the web application on the web server for every server that needs to be protected. Whereas we create that one profile I just showed you, which is so quick to create, and we're done. That's it. That's a big differentiator. So now the user wants their login page, so they just send their requests like normal, goes through BIG-IP. When the response comes back, this is where, as we saw earlier, now the WebSafe profile is what adds that JavaScript component and sends the response. So now the user sees their logon page, like normal. Unbeknownst to them, it also has some additional JavaScript code inside of there in the back end, which, by the way, they could see if they went to view the source of this page. But there's tons of JavaScript on every web page that most of us have no idea what it's doing. This brings up our second differentiator. Most of our competitors' solutions require clients to install an agent in order to make the fraud detection work. They have to install an agent. They get a little pop-up that says, do you want to install this? And they have to click on yes. So let's think about what we're telling them. We're telling them, don't click on yes buttons, except make sure you click on ours. And so what happens is our competitors, their user adoption rate for their solutions are quite low. Like around 10% of their users actually take advantage of the malware detection available. For ours is clientless, agentless. There's no agent needs to be installed. So every client that has a Java-enabled browser is protected. So we have a near 100% user adoption for our solution. Again, that's another big differentiator. So now the user has their logon page. Now malware runs. Malware inserts the PIN field. Immediately, as soon as that happens, that alert is issued from the client, goes through the BIG-IP, goes to the SOC. That's the good news. That's the really good news. Now, unfortunately, there's some bad news. In the meantime, the user can still fill in their information. They can still click on go. The correct information goes to the web server as expected, but the other data that the malware grabbed still gets sent to the drop zone. And again, this is what we talked about earlier. They might say, well, then why do we care? Why do we care if you can't stop it from happening? None of our competitors can stop it. It's not possible. But again, as I said earlier, we now have a team here. We have a team dedicated to helping these poor suckers out here that keep getting infected with malware and losing their credentials. So now our SOC can work with the customer. We can look at the alert. We can understand who the infected user is and what malware they have. Then it's up to the customer, really, to reach out to this person and say, hey, you have malware. You need to change your password immediately. You need to run this. You need to remove your malware, blah, 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 whatever they do. Because it's now up to them to remove the malware off the computer. Come on. I had to make it fun because I can tell you're a little dreary-eyed here. So here's why we use, or actually I shouldn't say why we use it. We haven't really used this word yet. There's a term called obfuscation. Obfuscation. You want to say that like 10 times out loud before you go talk about WebSafe. Obfuscation is really just a glorified encryption, but it's heavy-duty encryption. So here's an example of some script code. Here's an example of what it looks like when it's obfuscated. This is what WebSafe does to it when it sends it to the client computer. And that makes it virtually unreadable to the human eye. And that includes to the hacker's human eye. And WebSafe updates those keys that create the obfuscated code very regularly. So even if some hacker could somehow reverse engineer this, it's only going to be useful for them for seconds. So I like to say it makes it next to impossible to look in to figure out what that code does. That says highly unlikely, but I'd change that to next to impossible. So here's an example of the code of a web page without WebSafe, and here's an example of the code of a web page with WebSafe. Lots of code in there, and again, if you go look at any complicated website and you look at the code, there's so much code in there that you don't know what it's doing, and if you're like me, you don't care. I don't care. As long as I can get my tickets for my plane travel, I don't really care what's on the website. But for a hacker, they're not going to know what to do with this. So the last thing, and then we'll do our next exercise. The question, why can't WebSafe stop malware? Why can't it? Well, to answer that question, let's review a little bit about BIG-IP and how it fits into the world, into our world, in our organization. We have our data center, we have our BIG-IP, we have our applications. That BIG-IP is running a variety of different F5 services, AFM and ASM and APM and so forth. A request comes in, and all these, whatever we have configured, can examine the request and do a multitude of things with it. Compress it, and SSL offload, you name it. And only if it passes does it go through. But look at all the things we can do. Layer 2 through 7 DOS attacks, layer 3 and 4 network firewall, layer 7 web application firewall, authentication, authorization. This should sound familiar. It's what we've done for the last several days, right? SSL offload and optimization as well. The key here is the reason we can do all these things to this request is the request is going through BIG-IP, right? That's what BIG-IP does. That's what we do. We sit in the middle of clients that are accessing applications, and that enables us with full proxy architecture to do so many great things. Fantastic. But the important note there is this. F5, the BIG-IP, can only block what it can see and what it can inspect. That's fair, right? I think we can all agree on that. Okay? So this user's now infected. They want the login page. We look at their request. Their request for the login page is completely valid. There's nothing wrong with it. They're not a hacker. They're not submitting SQL injection attacks. So we're going to send the request down and send their response. Now we have WebSafe in the mix here as well. So with WebSafe, we send that response with the JavaScript code. They see their page. The JavaScript code is inside of the page. Now, no JavaScript can prevent a page from doing something. The only way JavaScript could do that is to prevent all pages from doing something. Like somehow, I don't even know if you could do that, but theoretically if you could, a JavaScript would have to say, stop the page, disable any OK buttons or whatever. But that would disable it for everybody. So the JavaScript cannot do that. So now, in the process here, this poor infected user has sent their credentials to the drop zone, unbeknownst to them. But there's a problem here. The BIG-IP is not in the middle of that communication. It can't see what's happening between that client and this server. And remember, the BIG-IP can only block what it can see and what it can inspect. So we are not alone here. None of our competitors can stop this from happening either. I hope that explains that a little bit. You can explain that as well to your customers. So this is the more lengthy lesson. The next two lessons on phishing and application layer encryption, super fast. So in this next exercise, you're going to now create a WebSafe profile for your banking website. You'll add some malware detection, and then you're going to just do some things that will generate alerts, and you're going to use BIG-IQ, because BIG-IQ is our alert server. So you're going to use BIG-IQ to view all of the alerts that you are hopefully successfully submitting. And that's really the key here, is seeing the visibility of the alerts. All right? So we've got about 40 minutes. It's about 3:28. So let's see where we are, about 4:10. We might go a little late today. I'm more tired than you are, so bear with me, or we all have to suffer. But I really want to make sure you guys get through all this. Like I said, it's my last day with you.